Hello everyone, this is David. Today we are going to talk about projectile motion at an angle, meaning for example you throw something in the air at a specific angle. The structure of this video will be something like this. In the first part, we are going to cover some very essential concepts that you have to understand in order to do the calculations. The second part will first neglect the air resistance and talk about the motion of a projectile at a positive angle. The third part is about negative angle, and the fourth part, as you can probably imagine, is the motion of a projectile when it is launched at a positive or negative angle but with the effect of air resistance. Now we are going to discuss some concepts that you need to understand. The first is independence. Any given point in the motion of the projectile, it can be divided into two components, a vertical and a horizontal one. And we usually need to separate them before we do any calculations or analysis because they behave very differently from each other. For example, the velocity, the displacement are all different. However, there is one thing that remains constant no matter vertical or horizontal component, and this is actually my second concept, is time. Because when you throw a ball into the air, it cannot land twice, right? It only lands once. Therefore, the time is constant for no matter which component you are considering. And this fact may become very handy when you do the calculations. The third point is a maximum height. If you are launching the projectile at a positive angle, the path that it travels will be a parabola, and the vertex of this parabola is the maximum height. If you are throwing the ball at a negative angle, then the maximum height we don't usually refer to as maximum height, but if you want to talk about it, it is the initial point. The fourth point and the last point is the angle. This seems ordinary, but it's quite different in terms that we usually measure angle relative to the horizontal axis. In this section, we'll discuss the projectile motion when it is launched at a positive angle, and it works something like this. Before we do any calculations, let's do some analysis first. In terms of the horizontal component, its velocity and acceleration will remain constant because there is no external forces acting on the ball after it's released, since we are not considering the air resistance. The displacement, therefore, is very straightforward. It will be a straight line crossing the origin with this displacement of the velocity value. The vertical component, however, is a bit more complicated because it's vertical. It is always subject to acceleration due to gravity, which is negative 9.81, and therefore its velocity will be changing, and the path or the displacement that it goes will be the path that it travels, which is a parabola. Now I will share some tips that you may use in the exams. The first tip is that when you are given velocity, you can always use this information and trigonometry to calculate two separate components. In the picture I have pasted on this PowerPoint, you can see that the vertical velocity always equals to sine theta x being the given velocity, and the horizontal component equals to cos theta x, which is the horizontal velocity. And the second tip, at any maximum height, the vertical component always equal to 0 because the acceleration due to gravity reduces velocity to 0. Third, when you are giving time and velocity and you are asked about range, you can always use the horizontal velocity, calculate the horizontal velocity, and use that information to multiply the time you are given. Because as I said, the time will remain constant no matter which component you are talking about. Then the maximum range is always achieved by 45 degrees launching angle, and you can experimentally determine this. The last tip, who is faster? The horizontal initial velocity does not affect the flight duration, meaning that if you drop a ball or throw a ball exactly horizontally, they will land at exactly the same time. In this part 3, we will consider the projectile motion when it is launched at a negative angle and without the impact of air resistance, and it goes something like this. So we'll do the analysis first, and honestly this is quite similar to the one we did earlier, and so I will not repeat them, but one important difference is that velocity is changed. In the previous one, the velocity is decreasing because it was moving upwards and subject to a decreasing velocity due to the gravity. However, in this time, we are not going to throw the ball upwards, therefore the velocity is keep increasing, but in a negative angle, in a negative direction. In this section, we'll discuss the impact of air resistance to the motion of the projectile. And this will work something like this. When we neglected the air resistance, the ball has no external force acting on it on the horizontal axis, and on the vertical axis there is only gravitational pull. However, when air resistance is considered, then the horizontal axis no longer remain constant because there is a force consistently acting on the opposite direction. Vertically, there will not only be the gravitational force but also air resistance, reducing its displacement. To conclude, in this video we have covered three scenarios. The first is projectile motion when it is launched in a positive angle, the second is at a negative angle, and the third is the impact of air resistance on the both motions. I'm not going to go over and repeat what I've said, but if there's one takeaway from this video, it is going to be the separation, or as I call it, the independence principle. When you are analyzing or calculating the motion of a projectile, you have to first separate the vertical and the horizontal components in order to effectively do so.